This is the second how-to video on identifying organic unknowns from experimental data. The first video steps through one or two basic techniques in answering this type of question. So if you haven't seen it, I suggest that you stop this video and go back and look at the previous video. The way we begin this type of question is to determine the empirical formula. And we do this in the following way. Compound C is composed of 85.7% carbon and 14.3% hydrogen. So we need to work out the ratio of carbon to hydrogen, and we do that here. We take the 85.7% and divide it by the relative atomic mass of carbon, and we take 14.3% and divide it by the relative atomic mass of hydrogen, which gives a ratio of carbon to hydrogen. And we quite simply then divide the numbers that we've got by the smallest number, in this case the 7.14, which gives us a ratio of carbon to hydrogen of 1 to 2. So our empirical formula is CH2. Now, section B tells us that whatever our molecule looks like, in other words, whatever multiple we have of the empirical formula, well, it's going to be a small number because compound C is a gas, and gases imply small molecules. If we have 40 or 50 empirical formula units added together, this would tend to move from being a gas to a liquid. So we know we're dealing with a small molecule. And if we look at section C, we need to remember that 1 mole of any gas occupies the same volume under the same conditions of temperature and pressure. So here we have 1 decimeter cubed of compound C. So we can assume this is 1 mole reacting with 6 decimeters cubed, or 6 moles of oxygen, to give 4 decimeters cubed, or 4 moles of carbon dioxide, and 4 decimeter cubed, or 4 moles of water. So what we can do then is we can sum this into a reaction equation. And here it is. So, as with the previous example, what I've done is I've looked at, although the arrows are missing from the diagram, what we've got is our empirical formula unit, and the N refers to multiples of each of the elements in our empirical formula, reacting with 6 oxygen molecules to make 4 carbon dioxide and 4 water. And it doesn't take a genius to realise that for 4 carbon dioxides you need 4 carbon atoms over here, and if we need 4 carbon atoms, well, if we multiply 2 by 4 we get 8, which gives us 8 hydrogen atoms, and we get effectively 8 hydrogen atoms in the product water over here. So what else do we know from this final section? Well, we know that any compound that decolorizes aqueous bromine, or bromine water, must be unsaturated. It must be an alkene. So we know that the product we're dealing with is an alkene. So compound C is an alkene. It can have 4 isomeric forms. Be careful here, it's not isotopes, it's isomeric forms. And the isomeric forms it can have are but-1ene, cis-but-2ene, trans-but-2ene, and if you're unsure about cis and trans isomerization, you need to look in the early sections of the Year 12 course. And the final isomeric form is methylpropene. The question does not allow us to identify which of these isomeric forms that our compound C actually exists in, because all of them are consistent with the information that we've been given. Moving on to compound D, we follow the same structure in our response. First part of the question, identify the empirical formula. 26% carbon, 4.3% hydrogen, 69.6% oxygen. 26.1 divided by 12 gives us our carbon composition. 4.3 divided by 1 gives us our hydrogen composition, and 69.6 divided by 16 gives us our oxygen composition. Same rules apply, dividing these numbers through by the smallest number, which in this case is 2.17. We get a ratio of carbon to hydrogen to oxygen as 1 to 2 to 2. So our empirical formula in this case is CH2O2. Okay, now again what I've added in this case is a little bit of additional information. So what I've done is I've worked out the relative molecular mass of this molecule, and it comes to 46. So if we look at section B, we have a relative molecular mass for D of 46. And this tells us therefore that our molecular formula is the same as our empirical formula, because the 46 are common. So our empirical formula is this, and our molecular formula is this. Putting sections D and E together, we can deduce that compound D is actually a carboxylic acid, because it gives us a orange-red colour with universal indicator, implying an acid, and it does not give us a positive test with the 2,4-DNP, which would indicate we may have a carbonyl. So we can assume that we have a carboxylic acid. And this is confirmed in section F, because when compound D is added to ethanol in the presence of a few drops of H2SO4, we get a fruity smelling liquid, and we know that fruity smelling liquids in general imply esters. So we've got a carboxylic acid with this molecular formula reacting with ethanol to make an ester and water. And here is the equation. The only carboxylic acid available with this relative molecular mass is methanoic acid. And writing this down structurally, we have methanoic acid plus ethanol forming ethyl methanoate, because the O8 section, the tail of the naming section, comes from the carboxylic acid section, and the forefront of the name comes from the alcohol. So in this case it's ethyl methanoate and water, and that's the summary answer to compound D. Moving on to compound E, we approach it exactly the same way again. 15.4% of carbon, 3.2% of hydrogen, 81.4% of iodine, which equates to 15.4 divided by 12, which is 1.2 or 1.28 of carbon, to 3.2 divided by 1, which is 3.2 of hydrogen, to 81.4 divided by 127, which is 0.64 of iodine. Dividing all these three numbers by the smallest number, which in this case is 0.64, we get a carbon to hydrogen ratio of 2 to 5 to 1. So the empirical formula of our compound E is C2H5I, and that has a relative molecular mass of 156. Part B of the question tells us that the relative the molecular mass of compound E is also 156. So section B tells us that the molecular formula is identical to the empirical formula. So C2H5I represents the formula of one molecule. If we go on to section C of the information given, what we see is the compound E reacts with silver nitrate solution to give a yellow precipitate and an organic product F. Now there's two actual reactions going on here. Silver nitrate is the standard test for halides, which we would expect to see because iodine is an halide, and it gives us a yellow precipitate, which again we would expect to see because iodine produces silver iodide when mixed with the silver nitrate solution, and that precipitate will actually darken with time because it's also photosensitive. But the reaction is a little bit more complicated because it's actually a two-stage reaction. What's basically happening is the silver nitrate, or the silver nitrate solution, is reacting with compound E in two ways. And the first way is that the iodide, the organic iodide, is effectively reacting with some of the water molecules to form, in this case, ethanol, which is compound F, which we'll come to in just a short while. But the other product of this is hydrogen iodide, and this hydrogen iodide is actually a set of hydrogen ions and iodide ions in solution, and the iodide ions then react with the silver ions to give us a precipitate which is silver iodide, and that is the yellow precipitate referred to in section C of the information given. So these are the two reactions which are actually taking place. The first one is the reaction between the organic iodide, which in this case is iodoethane, reacting with water to make ethanol and releasing hydrogen ions and iodide ions into the solution. And the second reaction is the iodide ions reacting with the silver ions in solution to make the insoluble product, which is silver iodide, which is the yellow precipitate. And that's all the information that we can glean from this information given us about compound E. So compound E is iodoethane. Now we move on to compound F, and we're told that it reacts with sodium dichromate in acidic conditions to produce a product G. Well, it's actually been oxidized. So this confirms that our product F is as we suggested in our previous discussions of compound E. And compound E reacts to form ethanol, and ethanol will react with dichromate under reflux, and we refer to this because it's oxidation. We use the square brackets and the symbol O for oxidation to form what we believe to be compound G, which in this case would be ethanoic acid and water. And if we wanted to test this, and although that's not in the question, we could actually add some more information here and say, well, how do we know that we're actually getting this compound? And we might get some other information which says that compound G, which is formed, reacts with or produces an orange-red colour with universal indicator. So we confirm that compound G is actually ethanoic acid by reacting it with an alcohol, in this case propan-2-ol, and we get a nice pleasant fruity smell compound which tells us it's an ester. And typically carboxylic acids react with alcohols to form esters, which are characterised by fruity smells. And that's it. That's all of the questions on this particular worksheet. Hope this helps. Thanks.